Good morning. We are now discussing a few concepts of astrophysics, among which the first one is the apparent brightness. The apparent brightness of a star is defined as the total energy received from the star per unit time per unit area at the Earth's surface. The total amount of energy received per second per unit area on the Earth's surface from the star is called its apparent brightness. The apparent brightness with reference to Sun is called solar constant. The total amount of energy received from the Sun per unit area per second on the Earth's surface is called solar constant, which is the apparent brightness of the Sun. The apparent brightness can also be defined as the total energy received from any star to its surface area is called apparent brightness. It is the ratio. Now coming to the absolute or intrinsic luminosity. The total amount of energy radiated or given out by a star from its surface in 1 second in all directions is called its absolute luminosity. The one that received at the Earth's surface is called apparent. The one that actually radiated from the star, from the surface of the star otherwise in 1 second is called absolute luminosity. So if we consider the star to obey Stephen Boltzmann law and the two like the hot bodies, then the expression for luminosity is given by L is equal to 4 pi r square into sigma Ts power 4. If we consider the star to obey Stephen Boltzmann law like all hot bodies, then the expression for luminosity of that star is L is equal to 4 pi r square sigma Ts power 4, where 4 pi r square gives the surface area of the star, which is having a radius capital R. Sigma is known as the Stephen's constant and Ts represents the surface temperature of the star. Similarly, luminosity of the Sun is L of Sun is equal to 4 pi r square of Sun into sigma T power 4 of Sun. A circle with a dot at its center, represents the Sun. That is how we represent the Sun in astrophysics. And this expression gives the luminosity of the Sun. 4 pi r square is the surface area of the Sun having the radius R, and T gives the surface temperature of the Sun. We know that surface temperature of the Sun is 6000 Kelvin and radius of the Sun is 7 into 10 power 8 meter. And substituting these values in the above relation, it turns out to be luminosity of the Sun will be equal to therefore 4.52 into 10 power 26 joule per second. This is the total amount of energy radiated by the Sun per second. A portion of this energy reaches the surface of the Earth, and that we call it as the solar constant. The amount of energy reaching Earth's surface from the Sun per unit area per second normally is called solar constant, otherwise known as the apparent brightness, and that is given by B equals L by 4 pi d square, where d is the distance between Sun and Earth, and therefore L is equal to B into 4 pi d square. This is d of Sun. Similarly, for any other star, L is equal to B into 4 pi d square. Taking the ratio, dividing equation 2 by 1, we get L by L of Sun is equal to D by D of Sun whole square into B by B of Sun. Therefore, L is equal to L of sun into d by d of sun whole square into b by b of sun. That is, if we know the relative distance and the relative brightness, we can estimate the luminosity of any star. Thank you.